CD20 positive B cell depletion through Rituxan's proposed mechanisms of action. B cells are differentiated blood cells that play key roles in the immune system. Their functions include antigen presentation, antibody production, and cytokine production. Normal B cells support immune function, but aberrant B cell differentiation can give rise to malignant disease such as non-Hodgkin's lymphoma. Approximately 85% of NHL cases originate from B cells. As NHL progresses, lymphoma cells can spread from the lymph nodes to distant sites, such as the bone marrow, liver, spleen, and nervous system. During B cell development, a number of cell-specific surface antigens appear on the developing B cell surface. These antigens are called cluster determinants. The antigen CD20 is expressed on pre-B and mature B lymphocytes on over 90% of B cell non-Hodgkin's lymphomas, but is not found on hematopoietic stem cells, pro-B cells, normal plasma cells, or other normal tissues. Because CD20 does not detach from the cell surface, change its structure, or become internalized, it is a stable target for monoclonal antibodies targeted against CD20. Rituximab, is a monoclonal antibody directed against CD20. Based on preclinical studies, Rituxan works by binding to CD20 on both normal and malignant B cells, and is proposed to deplete them by the following three mechanisms. The first is antibody-dependent cellular cytotoxicity, or ADCC. ADCC can be triggered when Rituxan binds to CD20 on B cells and interacts with Fc receptors on an effector cell, causing cross-linking of the Fc receptors. This cross-linking may result in cytotoxic attack against that B cell. The second mechanism through which Rituxan is proposed to deplete CD20 positive B cells is complement-dependent cytotoxicity, or CDC. Rituxan binding to CD20 on B cells may activate the complement cascade, a multi-component system that protects the body from foreign substances. This cascade results in the formation of a large pore in the membrane, leading to osmotic lysis. The third proposed mechanism of action is apoptosis. Rituxan binding to CD20 on B cells can lead to cross-linking, causing an increase in intracellular calcium, which activates the caspase cascade. This process ultimately leads to apoptosis. Through these proposed mechanisms, Rituxan selectively targets and depletes B cells expressing the antigen CD20, an antigen which is located on the surface of over 90% of B cell non-Hodgkin's lymphomas.